So I've put together a simple financial savings calculation for a 4.5 megawatt cogeneration plant that will operate maybe for an industrial site that has an average load of 3.5 megawatts. So our savings, our gross savings of a project like this is really a function of two things. The electricity that we're going to displace by the cogen, which is now purchased from the grid. So we're running the machine on average at 3,500 kilowatts. We're going to, maybe we run 6 days a week, 18 hours shifts, so 5,600 hours. And currently we're paying 15 cents a kilowatt hour for the power. And so we're going to displace almost $3 million of our electricity bill on an annual basis. In addition, because we're cogenerating, we're recovering the heat from the power generation, we're going to make steam, which normally would be made in a boiler, which is going to use natural gas to make currently. So we're going to make about 25,000 pounds an hour of steam from the cogen. We talk about the energy content in that steam. We're going to run 5,600 hours a year. The cost of gas that we're currently burning in a boiler is about $5.50 a million BTUs. And that boiler has an efficiency of only 80%. And so this is where we're really seeing the benefit of cogeneration as opposed to two separate forms of energy. And so that's another almost $800,000 a year of savings. So this is the gross savings. Now that savings doesn't come for free. The savings costs money. So the gas turbine in this case, at the heart of the cogen, requires fuel. So for those 3,500 kilowatts over 5,600 hours, this machine is consuming 12,000 BTUs of fuel for every kilowatt hour it's generating. And we have to convert that. All of us engineers love the HHV, LHV conversion. So we're going to have about $1.4 million of fuel that we're burning in this cogen to realize these savings. The cogen, the turbine, runs hard and it wears out. And so we have to accrue for servicing this over the long term. And so we're going to buy a long-term service agreement which goes around $36,000 a month. And of course there's 12 months in a year. So that service agreement alone is going to cost us over $400,000. And then the other big element to a financial feasibility of cogen is, even though we are generating our own power, sometimes we want to contract with the local utility for standby power so that they can keep their wires and their distribution system ready for us. And so that costs about $4 a kilowatt per month. We choose the whole nameplate of the engine, the whole rating of the engine, and so that's another $200,000 a year of costs. So a system like this, in this application, all of these numbers, of course, are subject to change based on the particular site, but it'll be about $1.6 million of net savings from this project after we pay for the operation of the system. The capital cost number, the savings numbers don't count for any grants. At CEM, one of our specialties is to get as many grant dollars as we can, and so if we can lower this capital dollar value by grants, then this simple payback number will also go down and the asset will pay back faster. Also, we haven't considered any of the benefits of on-site power generation for reliability in this business case. So if somebody can, if a site can place a value on avoiding power interruptions, often we'll have a line in here that shows avoided power interruptions, and that will also be another savings that can help improve the bottom line. In today's economy, in today's energy marketplace, electricity, the price of electricity continues to go up, and that burden is being borne by, whether it be, again, universities or industrial customers who have to consume that electricity. And so the price for electricity continues to go up 12, 13, 14, 15 cents per kilowatt hour. At the same time, the price of natural gas, for example, because there's so much of it available, is very low. And so as those become farther apart, we call the distance between those the spark spread, because when you have a combustion turbine or a reciprocating engine, there's a spark in there that drives the engine. So we call that the spark spread. As the spark spread gets bigger, the benefit of cogeneration financially continues to increase. And so if you have a traditional plant with the efficiencies we talked about earlier, you have electricity that you're consuming at about 14, 15 cents per kilowatt hour. When you cogenerate, you have electricity, because you're recovering the heat, you're doing it very efficiently, you can generate power or electricity for use at 3 or 4 or 5 cents. So you're saving, for every kilowatt hour your plant consumes, you're saving anywhere between 8 and 10 cents per kilowatt hour, which is over the course of a year for a big plant is significant savings in the millions of dollars of range for a system, 3 to 5 megawatts. So it's a significant savings opportunity for anybody who does cogen.